Okay, so what is chemistry? We all know, we have studied chemistry last year also. Importance of chemistry is a pretty normal thing, that chemistry is very important in our lives, as it is the study of the most basic element of which everything is made. So now, let's just come to nature of matter. Basically, we all know that matter is divided into three parts. Three main characteristic elements: solids, liquids, as so I'm going to define them in the terms of volume and shape. So we all know this. So solids, they have definite volume as well as a definite shape. And then liquids, they do have definite volume, but they don't have the definite shape. They take the shape of the container in which they are kept. So liquids don't have a definite shape. And when coming to gases, they neither have a definite shape nor definite volume. Very simple, very basic. So these were the fundamental types. But at normal level, the macroscopic one, matter is divided into three types: the elements, compounds, and mixtures. So let's just run this on. So matter is basically divided into three things: the elements, compounds, and mixtures. Sorry for that. Let's just continue. So elements and compounds are considered as pure substance, as throughout the matter there is only one kind of molecule present. So they are considered to be the pure substances. Pure substance, as there is only one kind of molecule present throughout the matter. So, and now elements are molecules of same atoms, where compounds are the molecules of different atoms. Elements, this is the basic thing, the basic element, this thing. So these only have one atom. Whereas compounds, they may have, they always have two or more than two compounds. Atoms. Compounds have two or more than two atoms. And similarly mixtures, well, they are defined in two types: the homogeneous and hetero. I think that's going out of the frame, but sorry for that. Okay, I love this and all. Write it. Mixtures. Two types: homogeneous and heterogeneous. Okay, so now we all know homogeneous, heterogeneous, elements, compounds. So homogeneous, as the word homo, which means same. So homogeneous can say, in which we can say that homogeneous are the mixtures which have two or more different types of molecules but the composition is same. Mixtures, they have two or more than two types of atoms. I can say even molecules. For just sake of easiness, we are saying molecules as two or more than two types of atoms goes for compounds. So homogeneous, homo meaning same. So homogeneous, we know that the ratio of the molecules, the different molecules, the ratio is same throughout the mixture. Similarly, heterogeneous compounds are those compounds which have different composition, different composition. The total number of different molecules is same, but the ratio is constant. Homogeneous, we are having a container of say water and oil. That's the very basic example of heterogeneous one. Due to the difference in the densities of the two liquids, water is always below and oil is above. So this is heterogeneous. As the total number of molecules of water and oil summing up are same, but the ratio is different. Like on the top, oil is more and at the bottom, water is more. So that goes for heterogeneous. So now matter do have some properties and they are divided into two parts. The properties are divided into two parts, physical and chemical. And most of you must be aware, but a revision is always considered to be a good thing. So physical properties are those properties which can be measured or observed without changing the identity of the composition. So let's just simply write this here. Physical composition. Or identity. So these properties are the properties obtained without changing the composition or the identity. Whereas chemical properties do require a chemical change. To see and observe the chemical properties, you need to react that matter with anything you have, anything you want to. So then only you will get the chemical properties, like on this reaction this happens, this reaction that happens. So that goes for chemical property. Okay, so we are done with this part.